Hello, I'm 𝐓𝐞𝐬𝐭 and I'm going to present now the presentation of my final project which I did for the course Software Development for Robotics, and the project name is Pioneer Exploratory Robot. So on the project, let me introduce myself first. I'm 𝐓𝐶𝐭. I'm currently pursuing Master in Robotics at UMD CP. My current research works are I'm working with Professor 𝐓𝐞𝐬𝐭 to develop micro-flying robots for pest control applications. We'll be using a fleet of robots to monitor and kill bugs. The other work I'm doing right now is with Center of Environmental Engineering UMT, and I'm working on face tracking algorithm for portable air conditioner. My area of interest are computer vision, SLAM, machine learning, and if you want to know more about me and want to connect with me, here's my LinkedIn link. So I would like to tell you about my project overview. So this project was basically based on developing a system capable of navigating and mapping unknown environment. I used ROS framework for this and Gazebo simulator with Turtlebot 2 as a robotic framework to develop my system. There were other capabilities also which system is capable of achieving, such as robust obstacle avoidance, occupancy grid map generation, image capturing, start and stop control, velocity control. I'll be coming back on these capabilities to explain why these are important in this application. Yeah, this is one of the most important part of this presentation. So these are the salient features of my project. So the project was done using object-oriented design C++, and I followed a solo iterative process to develop the system. Also, it uses new C++ feature of 11.14. The unit test and ROS test implemented. Also, the continuous integration has been set up in Travis CI. The code coverage is greater than 90%, and the good part is license is MIT, so you can use it. Code documentation is also there using deoxygen so that it's clear to the users. So these are the main features which I'm presenting before you. Let's move on. So why I did this? What was the motivation? So the main motivation was these kind of system autonomous operation have multiple uses in multiple scenario, and also I was trying to develop some low cost system as like Turtlebot is off the self low cost robot with a depth camera, which is certainly a cheap option for developing a robotic system. So the application which can be used where this system can be used are disaster relief. Something happened and human cannot go, then this robot can go. Construction site monitoring also one of the purpose which so that this product can also be commercialized once it's developed. For mapping, it can be used like new construction, what are the progress of construction, it taking the images and all. Also leak happen, gas leak, hazardous leakage, then humans are not able to go inside because of health risks, then this robot can go and give some help to human or assist the damage. Also, this system can be used for map generation, which can further be used for autonomous navigation of the robot on later. Also, the one of the important part is since it's developed on the software, there is no difference when we are going to implement in real hardware afterward, because I'm using ROS and Gazebo, so it will be directly implementable and in the real hardware. So let's go into the detail of the design. So here is my UML class design for the project. I'm using 3 classes: robot camera, and exploration. Let me explain the different classes to you. So exploration class basically handles the exploration task. It has a explore function which actually gives the velocity, and it reads various flags and services. It also has a function to read the laser scan data, and once it sends the laser scan, it sets the collision flag to true. And it also has two services, motion service and velocity change service, which are being used to start and stop the robot and also change the velocity. There are 2 timers also which will be utilized in making some exploration action. Okay, this was it for exploration class. For the robot camera class, basically I have a service which is used to take pictures and a callback function which reads the laser scan data, which subscribe to laser scan data and implement the image capturing action once it get a flag from the service. And the robot class basically integrate these two class objects and run the main method run, which calls the explore method of exploration class. And so all the subscriber and publishers are declared here in the robot class only, and which integrate basically both the whole system and run the system. Also, I have included the dependency. So OpenCV is the dependency for this project. Here's the activity diagram. Once I start the robot using the launch file, 𝐓𝐞𝐬𝐭 and gmapping nodes are active. RV is also opened. Once the node is open, here you can see the collision avoidance sequence. So we read the laser scan data, and if something is there, we rotate randomly here. Or after every 100 seconds, we rotate for 3 seconds to generate some random exploration behavior so that we are not stuck in place. Also, once the laser is active, we can all call the 3 services I mentioned earlier, and then we can check if we are satisfied with the map. Then we can save the map using map server and stop the exploration using Control-C in the terminal. So now I'll be delving into the build and demo stuff. So these are the build instruction. It's on the GitHub repo also. But I'll be showing on the video how to do the build. So let's go into the video. So you'll be starting from this. As you can see the repo, there are dependencies also. So I will really recommend you go and read the README of this repo before doing anything. So here I used a git clone repo and cloned the repo. Then I am doing 𝐓𝐞𝐬𝐭 and also running run test so that all the unit test also runs at once. And you can see it will take a while to run because I'm testing the timer also, which is after 100 seconds, which comes after 100 seconds. So it will come. Let me forward it because we have to wait. Okay, so you can see the timer is called and there are 14 tests and all that passed. So now I'll be launching the image view launch using a Pioneer image view launch file, which will launch our demo. And you can do this using this command, ras launch Pioneer. Okay, now everything is opening up and let's see. Okay, so here is the gazebo window. It's open now, and slowly you can see. So here you can see the direct camera feed from the robot, which can be used for various purposes, monitoring and people tracking later. Okay, let me set up. Okay, so now I'll be exploring some services which I mentioned to you, and I will show you how to run those things, run those services and get the output. And also my demo works, my system works. It will prove that to you. You can see on the left in the RViz the laser scan data and the map which are being generated in the RViz. Okay, so for this we'll run raw service call and the service name. So the first service name is okay, I think it's motion service. Yeah, motion service true. Then if I type motion service true, then you can see the robot will stop here once I do, and you will get a response that it's true. Okay, now I'll do it false and then start running again. So this service is used for like pause and play to the robot. If it's running, then it will stop. It's moving. Okay, the next service, velocity change service. You can see right now it's 0.3 meter per second. I'll change it to 0.1 and you can see it's like now slowed down. I'll again set to 0.3. Okay, now the image capture service. So for that, the service name is capture image service. You can call in the same manner, and then after that you have to write true. Okay, Okay, then you can see here it was a command which showed that image were captured. You can open it using Genome Open, and it is saved in .ros directory. So here is the image which I captured. So you can see all the three services works very well, and also you can see the mapping in the left, like it's almost 2 minutes and we are almost there, like most of the obstacle has been already mapped, and you can see how the map is coming up, the 2D occupancy grid map. You can save this map using map server. Okay. So this was the map service command you can find in the GitHub, and more other info also. Let's move on. So this is the output which I obtained almost after like running for 3 or 4 minutes. I think it's pretty good considering the algorithm, like because the algorithm is running just some predefined velocity routine and some random velocity. And of course, I'm using timers which after 100 seconds give some rotation to the robot so that we have to increase the exploration behavior. So I think the output is pretty good. But yeah, future work. So what I'm lacking and what can be done. So we can add a frontier-based exploration method for exploring large open map, because this system will suffer, believe me, in the large map. Yeah, it will take so much time, and it will go here and there. So also we can implement the whole navigation stack using the map created by this system, which is very useful. Also, we can develop a 3D mapping which is more accurate using the depth information of the camera, and it will be more improved version of this, like using 2D occupancy grid map. Also, you saw that there were humans in the map, so using the camera we can do human tracking in some office environment or some workplace environment also, or disaster environment also. We can track, we can see the condition of the person. And one more thing, that this software is developed for the turtle bot. It was kind of easy because all the data were there, but also it can be developed for a custom robot from scratch, like generating robot data or messages. So that will be a challenge, good project to do. Okay, thank you. If you have any queries, please shoot me a mail. I'll be happy to answer anything. Thank you.